Okay, so now today we are going to start something called basic calculus. So calculus is essentially developed as a mathematical tool, and calculus itself is not a very fundamental mathematics. It is called the applied mathematics, which uses the existing mathematics in certain way, but it looks of its a different form, and it was developed by two great mathematicians. One is called the Sir Isaac Newton, another is called the Gottlieb Leibniz. So the two mathematicians are behind this applied mathematics, I would say. So one is Newton, another is called Leibniz. So these two are essentially credited with the development of calculus.
Hello, sir.
Yes. Okay. Okay. You have to write this in.
Hello, sir.
Yes.
Sir,
Tell
my
me.
network connection was. Sir.
Okay. Okay. You can listen to me now.
Hello, sir.
Yes. Yes. I can listen to you. I am hearing you. Hello. 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 I am hearing you.
Yes, sir.
Yes.
Yes,
Yeah.
sir. Sir, I was telling that.
Mhm.
Please, will you repeat what you said just now?
No, no, I didn't say something great. I simply said that okay, the calculus is a applied mathematics. It is like a invented mathematics, and it uses the concept of the pre-existing mathematics, but with some new notations. Okay, so it's like you have created a bunch, whole bunch of new symbols, and with some meaning to it, and we are going to learn those things. And this branch is essentially developed by these two great giants. The one is called Newton, and another is called Leibniz. So they have developed this calculus. Okay, so in calculus,
Oh,
what we are going to learn? Okay, what will be the learning from this chapter? So we are going to learn something called functions. We are going to learn something called limits. We are going to something called continuity, and we are going to learn something called differentiability. In the differentiability, we are going to learn about further differentiation, integration. In integration, we are going to learn about called the concept of elementary, meaning of area and volume. In differentiation, we are going to learn about called slope. We are going to talk about maxima and minima. We are going to learn about rate measurer, and okay, maybe something else. So this is the learning outcome of this particular topic that I will be covering here. Other part of mathematics will be covered by other teachers like Amit sir and Anand sir must be taking your math lecture. So my role here is confined to calculus. Okay, so we also learn about something called graph. So how to plot a graph, okay, how to read a graph, and how to manipulate a graph. Plotting, reading from graph, and graph manipulation. Now, function itself is a huge topic, okay, and it is taught from the class 12th level till the, you can say, PhD level. The way of teaching will change from level to level, and calculus is essential to the learning of various machine learning techniques. So various, if you know, because the world is all about machine learning and artificial intelligence and all these things. So in the future, not exactly now, but in the future, these tools and techniques will be very helpful. So not only for JEE mains or advanced, it is also equally important to know these topics if you have some interest or curiosity in future to learn about these newer technologies, which is already there. But by the time you will be there, it will be like much more refined and much more advanced. Okay, because it's going to be almost 6 years from now. So by that time, you will be seeing a whole new world. Okay. Okay. Anyway,
So,
yes.
so which topic is it? So I have very poor connection, so I can't hear your voice.
This is called calculus. I have written the name calculus. Calculus.
So before that, what is it?
Okay. And calculus, in this calculus chapter, we are going to learn these topics. Okay. So we have functions, we have limits, we have continuity, we have differentiability, and then we have a whole lot of something called differentiation. I can put integration separately because that's a separate topic, to be very honest. So it's good to put it separately. So let's put integration separately. Let's make it a separate topic. Okay. So first of all, we'll talk about function. Before that, we'll just talk about something very basic. And I hope that you have just aware of something called set. So set is generally defined as a collection of well-defined objects. From the mathematical point of view, the set will be all about numbers. So set of different set numbers is what we are looking for. So let's try to understand the concept of a function in this way. So I'll start with some example. So let's say this is the time. So imagine you leave from your home to your school. Okay, so you're leaving from home to school, and I want to write a set of time and the corresponding distance from your home where you will be. So when time is zero, like when you start walking, it's a stopwatch, let's say. So when you start walking, the distance from your home is 0 kilometer. Okay, so this is how you start it. Now, as the time will progress, more and more time will be spent. So let's say you have spent 5 minutes. So let's say everything is in minutes. And since you started walking from your home, so after 5 minutes, I can imagine that you have traveled something, and I can say, oh, you have traveled, let's say, 0.2 kilometer, not much. Now at 0.2 kilometer, you have your friend's home and you were waiting for him to go further together because uh, his home is in the same route. So you thought of, okay, let's go together. So you call him and then he comes down and then you go along with him for the school. But in doing so, you spent 5 minutes there standing and waiting for him. So now time is 10 minutes, including the waiting time. But how far you are from your home? The answer is still zero point 0.2 kilometers. And then you both start moving together, and then you walk for next 10 minutes continuously. It is almost 20 minutes, and you together have traveled, let's say, zero point 0.4 kilometer extra. Now you're at a distance of 0.6 kilometer. So in this duration, you traveled how much? 0.4 kilometer, and then now you're at a distance of 0.6 kilometer from your home. But after traveling for 20 minutes, you feel very hungry, and then there is a like vada pav wala. So you're craving for the vada pav, so you wait. You both of them of the thought of let's have one bite, at least one vada pav, and so you again spent the next 5 minutes eating vada pav. So although the time has changed, but because you're eating, so your distance from home remains same. You finish your vada pav, you have some water, and then you again start walking, and the school is very much nearby. So in the next 5 minutes, you reach your destination, and because it's a less than 1 kilometer, so you thought of going walking, else you would have taken auto or something. So now you reach your destination. You spend the entire day at school. So maybe after I can put one more zero, like it's minute and it's a second. So you spent almost, let's say, 6 hours and then 30 minutes, 0 second, and then you the I when at this moment you are at a 0.8 kilometer from your home because you are in the school only, and then you come back to your home. So the distance will even decrease if you go towards your home. So now this is the collection of time which I have taken for my reference, and on the right hand side we have a collection of distance. Of course, some distance are repetitive in nature. Okay. So in the world of set theory, if I ask you what are the distances that you achieved, so what are the like set of distances if I want to end my uh, the observation till this time, let's I am stopping my like the learning. So question is, if I ask the set of values which the distance will have, I can say set of values the distance will have is 0, 0.2, 0.6, 0.8. That's it. Because we do not mention something which repeats itself because it's the same thing. So I'm asking what are the values at which you calculated the time or vice versa. And if I collect the time sequence which I observe, it was 0, it was 5, 10, 20, 25, 30, and it's like if I convert into minutes, it's 360 plus 30, 390 minutes. Okay, like this. So now this is called the set of time when you know saw the distance values, and this is the time distance values which you actually observe. Although it's a continuous variable because you have walked from 0 to 0 to 0.8 kilometers, so every other value must have gone through. But I'm not making the recording of all those values, else it will become very complex because how many values are between 0 and 0.8? Can you tell me how many values are possible? How many distance you can have between 0 and 0.8 kilometer? How many recordings are possible? Hello, hello, hello. 1, 2, 3.
Sir, can you repeat the question?
Question is how many recording of distances are possible between 0 to 0.8 kilometers? Like I have recorded few values, like let's say 4 values, 0, 0.2, 0.6, and 0.8. How many such calculations are possible?
Sir, but if you talk about one decimal place, then 8, but then infinity is also possible because if you keep on adding
Correct.
point
Correct. So
and
the
then
right answer is, yeah, the right answer is because it's a real number. So I'm not talking about the natural number or maybe I mean one decimal place restriction. So you can say for sure that there are infinite possibilities. Okay. So the distance can take infinite possible values over the range of values that we have taken from 0 to 0.8. And so is the time. Okay, so even time can take a infinite values between 0 to 6.3 hours or 6.5 hours, you can say. So these are called continuous function because it can take every possible value. So we say the function is the of course right now it's not function. So we say the set is the variable time is continuous variable, and the distance is also a continuous variable. So the time and distance here I have taken as a variable. So in science or in mathematics, for variable we choose some symbol, and the two famous symbol, it's not restricted to the two symbol, you can choose whatever symbol you want, but the two famous symbol are x and y. Now there is like a kind of unsaid rule which you can also realize is very much essential to follow, that one of the variable I have named it as x and other as I have named it as y. Now can you tell me which variable is kind of independent in nature and which is dependent?
sir, time is independent.
Correct. Because can
And
we,
this is
yeah,
dependent.
correct. Very good. Because can we control time? Can we stop time from happening? The answer is
No,
no. But the distance you can control because you can stand there and there forever and you will not change at all. So in mathematics, we have two variables. One is called dependent, other is called independent. And it is a very natural, I mean, to assume that the independent variable we keep on the x-axis and the dependent we keep on the y-axis. So this is the kind of a rule that we follow in mathematics. So when we draw a graph, like when you plot the graph between the distance and time, the distance should be taken on the y-axis and time should be on the x-axis. So as a general, I would say rule, every dependent variable we plot on the y-axis and the independent on the x-axis. So it goes without saying actually. It goes without saying. You can just believe me. So first of all, define the variables. Okay. So variables are something which varies over the given observation. Variables are values which varies. No, that's it. So we have two types of variables. We have two types of variables. The first is called independent, and other is called dependent. So independent variable we represent by x coordinate or x axis, and dependent we represent by either y coordinate or y axis. You can say like this. You can name it like this. Now symbolically, it should not be x and y. It can be anything like I have time here. So here my x is t, and I can say my y is s. S I'm taking as a distance. So graphically, here the two variables, the t is on the x-axis and the distance is on the y-axis, and then we plot the corresponding value. So we have 0 comma 0 here, we have 5 comma 0 0.2, so 5 minutes, and then 0 0.2 maybe somewhere here. Then we have 10 minutes and same value 0 0.2. Then we have 20 minutes. Oh, it's like you know how to plot the graph. You have done in your childhood how to plot graphs. I think it's not very difficult. You can extend the line, and when time is 5, 10, 15, 20, you are at the point 6, so it is somewhere here. But when you plot something like this is called the dots, one dot, two dot, and because there is no continuity of points that we can plot, so such graphs are called discrete graph in the language of mathematics. What we say, discrete graph. Discrete means only dots you can plot. You cannot make a curve, a smooth curve. So we have only fixed set of dots, and we have a discrete graph which does not look good. It's just having collection of points which you have just put on the paper. So going forward, we will be interested in something called continuous graph. Okay, and continuous graph will have a very interesting relation that it will take on all values of independent variable, and it will plot a corresponding value on the dependent variable, and then you can make a continuous plot actually. Although if a graph is continuous or discrete, the drawing of a graph begins with plotting the points. Okay, so however smooth a graph may look like, it is nothing but a collection of a large number of points, infinite number of points. So when we learn about the drawing of graph, we'll start with plotting of points itself, and then we'll use some other feature of mathematics to actually get the right shape of it. So anyway, that will come slowly and slowly. So again, so here we have two set of variables. One is called the independent and another is dependent. And there may be some relation between these two. A relation as we use in the common language, same thing we use mathematics, but it's more refined in mathematics. A relation is a subset of the Cartesian product of two variables. So that's very maybe harsh on you. So relation is a subset of some Cartesian product of two sets A and B. So I'll just show you something interesting. So let's say what is the meaning of this entire symbolic thing? Let's say A is a set, and A contains 1, 2, 3, 4. Just take values. And let's say B is just another set which contains 1, 4, 9, 16. So maybe in class 9th or 10th, you have learned about the Cartesian product. When I write A cross B, it does not mean multiplication. It means all the possible combination of A and B. Like what are the combination? You know the combination meaning. Okay. So let's say you have, I will explain what is combination. Let's say you have two shirt or t-shirt and three pants of different color. So let's say we have T1, T2, two t-shirt of two different color, and three pants of P1, P2, and P3 of three different colors. So if you on a given day, if you want to wear some t-shirt and pant, so in how many ways you can choose the pair which you can wear? So you can go for T1 P1, or you can go for T1 P2, or you can go for T1 P3, or T2 P1, T2 P2, or T2 P3. So what is the total number of pairs you can wear actually on that day? You have possibility of how many possible situation you have. So with a 2 t-shirt and 3 pants, actually you can occupy 6 different days with a different combination. And if you look at the number of, this is called the number of ways in which you can wear the clothes, and the number of ways is nothing but the number of t-shirt into number of pants. It's just the product of the two, right? And these are the combinations. Of course, these are called combinations. So this is called the Cartesian product meaning. So when I write A, so we have 4 possible values. B is having again 4 possible values. So A cross B will have 16 possible values. Okay. So it will have 1 1 1 4 1 9 160. So the one can go with any 4. So we have 4 values. Then again I can add for the same for the 2. So I'll just change the color. So 2 1 2 4 2 9 2 16. And then we can go for 3 3 1 3 2, sorry, 3 1 3 4. 3 4, then 3 9 and 3 16. Oh, I should change the color. So 4 1, then 4 4 4 9 4 16. Okay, so what you can see that if I want to relate A and B, then these are the possible relation that we can have. Okay, this is like a, no, this is not relation. This is called the Cartesian product of A and B. So A and B, the Cartesian product of A and B is called the Cartesian product of set A and set B. So now you guys, you can see that how many combinations we have. Okay, so we have total 16 combinations, right? So now I want to choose those combination which is having some meaning. For example, I am interested in one particular combination called 1 1 2 4 3 9 4 16. So out of 16, I have chosen just 4 combinations. And in the 4 combination, if you look at the entry in the bracket, in the parenthesis, we have 2 entries. The first entry and the second entry. First entry, second entry. First entry, second entry. And because we say as a Cartesian product, the first entry is called X, second entry is called Y. So X comma Y is called the ordered pair. What do you say? What does it mean is that 1 comma 2 on a graph and 2 comma on a graph will represent 2 different points. It's not the same. That's why it's called ordered pair. Anyway, tell me guys that do you see any relation between the first entry and the second entry?
Yes, sir. It is the square of the first, like y. X. It's a square.
Yeah. So if I can say with confidence that y is nothing but the square of the first entry, which is x. Okay. So the y is the entry. I can. This is the way of writing it. So y entry, the nth entry of y, is the square of the nth entry of the x. So this is the relation between the 2 entries called x and y. So we can see that from the whole bunch of ordered pairs, only few pairs having some relation. Or it could be possible that we have all pairs with some relation. Okay. So depending on how we define the relation, you may take some value out of the A cross B, you may take all values out of A cross B. For example, if I ask you that how many pairs are there in which the first entry is less than second entry. So I'm defining a condition and then I'm saying that can you pick up the ordered list which fulfills this condition? Can you guys tell me? Like the list of ordered pairs which fulfills this condition. That the first entry is strictly less than second entry. So you can say 1 4, 1 9, 1 16, then 2 4, 2 9, 2 16, then 3 4, 3 9, 3 16, and then 4 9 and 4 16. So out of the whole bunch of Cartesian product, the one which qualifies my definition are only these many. So it's a subset of the entire bunch. So relationship is something which we define. So let's say I want a set of ordered pairs in which this relation holds. And what is the relation? The x should be less than y. Okay. So when you say x is less than y, so you define one relation and then you try to look for those ordered pairs which are part of this relation, which fulfills this relation. So what you end up getting is another subset of the Cartesian product. So what is the meaning of Cartesian product? Cartesian product is the all possible ordered pairs with relation or without relation. They may have relation, they may not have relation. And then when you define a relation, then you want to pick those values which fits your definition of a relation. And that is how we define in mathematics that a relation, look at this here, a relation is a subset of Cartesian product and it is defined by you. Like you choose what will be the definition. I cannot say anything. So in mathematics, a relation is first defined and then the subset is chosen. I hope this is clear what I'm trying to convey. A cross B is well defined. A relation is a subset of A cross B. Okay. And in the subset, you will pick only those values which fits the definition of a relation which you are trying to define. ये बात समझ में आ रही है बच्चों आप लोगों को? तो डिफिकल्ट लग रहा है? Hello.
Sir, I have a question.
Yes, tell me.
Sir, over here you wrote x is less than y, so that is the condition.
Yeah.
And then all the pairs in the set are the ordered pairs.
Yes.
Okay.
Yeah. So every first entry represents the x and every second entry represents the y in every pair. That is for sure, without any ambiguity. And now I am looking for those pairs in which the first entry, that is x, is less than second entry, that is y, strictly everywhere. Then I found these 11 such values. So out of 16 values, I have 11 values here. Okay. Any other doubts? Athar, your doubt is clear now?
Yes.
Okay, who is saying? Who is saying? I think Harshit. Yes, Harshit, tell me.
So given that the relationship which suppose you have written your
Yeah, I think your voice is breaking a lot. So can you write on a chat, because your voice is breaking a lot. So I'm not able to exactly listen to you what you're trying to convey. So that will be helpful. Just write on a chat and I'll read it out. Anybody else want to ask something? Yes, definitely. The A cross B is a subset of itself. Every set is a subset of itself, because you can take all of the values from the set. Okay, so in that way it is called subset. So if you learn subset theory, you will learn two things of two types of subset. One is called the proper subset and another is called dust subset. So when I say subset, I don't use the prefix proper. Then you can take the entire set as your subset. But when we say proper subset, because see, if you look at the relation symbol, R is either R can be chosen from A cross B, or R can be equals to A cross B. So that's why this symbol. C represents chosen. R is a set of values which you pick from this value, or it can be equals to this value, and that is why we have this symbol, subset symbol. So the word subset uh, or equals to, when I put this horizontal line, it means it can be equals to this also. But when I remove the line, it means you cannot take all values. You have to pick at least one less. This is called proper subset, and this is called subset. So I hope the symbol is making sense to you now.
Sir, is it like greater than equal to
Ah,
and less
yeah, it's
than?
like yeah, you can say less than equals to. Yeah, so it is like less than equals to. That's correctly answered, but this is not exactly less than equals to in value. So we write like this. So, and when I remove the equal sign, so it's called proper subset. This is not very difficult to understand, because I think this is what we learned in class 9. Okay, anyway, but the symbol meaning is clear to all of you guys, or are you finding it still difficult? Harshit, the doubt is not clear. Okay. So anybody else having the doubt in terms of symbol or what I am writing? Atharv, Pratiksha, tell me. If you have guys understood, then I can move forward. Okay. So
No doubt,
first
sir.
of all, okay, very good. So now you have to understand. You have to understand two things. Okay. The first thing is called uh, set. Set means collection of points. You can imagine in mathematical terms, a set is a well-defined collection of points. That's it. Points can be positive, can be negative. It may be in a quadrant, which we know. First quadrant, all positive. Second quadrant, one entry negative, one entry positive. Third quadrant, both entries are negative. Fourth quadrant, one entry is again positive, one entry is negative. So every point in a plane or in a three dimension also, okay, we'll have some sign plus minus whatever. So when we say two set A and B, it means I am defining set of points in two different ways. Okay, and then I'm trying to define the relation between these two. Sorry, the Cartesian product between these two. Like using this set and this set, how many different couples we can create, the pair we can create. So that will be represented by the A cross B symbol. It does not mean you're multiplying it. It is a way to say that I'm trying to find the A and B ways of creating the entries. Okay, that's called A cross B. A cross B means the number of ways. That's why I have written here number of ways. So A cross B is 2 cross 3, that's 6. So this is how we write it. And then you get a set of combination. This is called all possible values. Then you define a relation which is like a filtering panel. You can say it's a filter. And when you pour the A cross B through a filter is like a relation which you define. So depend on the filter definition, you may get a new set with either some of the value or all of the value. Okay. So we have stages of definition. One, first we define the all possibility, and a relationship is some of the fixed possibility of your interest, and you take your interest as a filter. Okay. Nowadays in Insta we say no filter and filter. Okay. So you design a filter called relation. So relation is like a filter. That's it. Relation is like a filter, and you pour some of the A cross B, and the one which fits the definition of filter will go through it or will pass it. The rest will remain on the other side. So what you get is a subset of A cross B. This is what I was trying to explain. And the subset will fulfill the relation. So I hope the word relation is not very difficult for you to understand. Okay. So relationship is okay. Guys, tell me.
Yes, sir.
Okay. So the subset of A cross B may be a relation. Let's say if no one fulfills the definition, then the relation will be empty set, right? Nothing will come. Nothing will filter out. That is also possible. Like you define something. Let's say if the first entry is 10 times the second entry, so in nowhere you will find the first entry is 10 times the second entry. So when you put a relationship which is not applicable on any of the A cross B, so you say that the relationship do not exist, okay, at all. Okay. So I'll take some non-mathematical definition of the relation. Okay. It's not always mathematical, but since our interest is in mathematical terms, so we say mathematically. Imagine something like a list of values. In the first set, we have, let's say, Maharashtra, Rajasthan, let's say UP, maybe MP, maybe Bihar. And on this oval, I'm writing, let's say, Jaipur, Patna, maybe Bhopal, Lucknow, and Mumbai. The moment I write this thing, you have the brain. You can understand there is a relation between these numbers in the left and numbers on like the values in the left and the values in the right. There is a relationship. What kind of relationship they have? What kind of relationship they have?
So they are all states.
Yeah. So it's called state capital relation. State capital relation. But how many subset we can so you can say if I say this is A, this is B. So how many values of A cross B can exist here?
25.
Very good. So out of 25, will all values will have meaning or only few will have meaning of state capital relationship? Is Maharashtra and Patna having some relation? The answer is no. So technically, Maharashtra can go with any of the five here, all the five, but none of them except the one will have a relation. So four will be discarded. So state capital is a relation. If you apply this relation on these two subset using their Cartesian product, only few will filter out, and the pair which will come out will be Maharashtra and Mumbai, Rajasthan and Jaipur, UP and Lucknow, MP and Bhopal, and Bihar and Patna. So now this only five possible ordered list will have a relation, and the relation here we are defining is called state capital. Okay. So this is how we make a filter, and from the all possible values of Cartesian set, we only pick out our desirable values, and that's why this is called relation. So a relation is a subset of Cartesian product of two set A and B with some meaningful, dependency. Okay, or in which the ordered list will have some sort of uh, relation, which may be mathematical, which may be non-mathematical. So our syllabus is all about a mathematical relationship. So I will not go more into the non-mathematical part. So relationship will have a huge variety of non-mathematical part also. So we'll stick ourselves to mathematical part. So mathematical part, if I say that okay, the same thing which we did earlier. If I say here we have 1, 2, 3, 4, and here we have 16, 9, 1, 4. So of course there is some relation that you can always relate. So one will go with one because it's a square value, right? So here, because it's a number, I will say x because these are, let's say, independent number, and this is y, this is dependent number. So I am just joining the dependent values. So 2 will go with 4. Yeah, that's nice. 3 will go with 9. 4 will go with 16. So what is the relation that we are, showing by the arrow? What kind of relation is this?
Squares of
the
a
number.
number.
Right.
Square,
The dependent variable y is nothing but the square of the independent variable x. Okay. So here these values are these are the y values. These are y values. So for every y belongs to y set. So and now I should like mathematically it's very difficult to write in. For every X belongs to the X set. X is a set in which there are many values, and small x is one of the values. So this is the way of writing in world of set notation. So capital X is we use capital alphabets for the set representation, and the small for the corresponding elements. So X is called element of set X. So X is the set, and small x is the element of the set X. So what I'm writing, for all x belongs to X, for all x belongs to S, there is a relation, there is a y, which is equals to square of x. So this is the mathematical relation. And in mathematics, if a relation is having some mathematical dependency, or if a relationship is a mathematical in nature, we prefer to call them as function. So the entire process was to just make you realize that a function is a relation only, but it is of mathematical origin. So relationship can be mathematical or non-mathematical, but to distinguish the mathematical relation, we have renamed as a function. So what we say here, that y is a function of x. In a way, y depends on x. Of course, x is an independent variable, y is a dependent, so y will depend on x. So if someone will ask you what is function, what is function? So function is again a relation between two set. Okay, function is a relation between two set. Okay, and which kind of set? The set in which the elements having the mathematical relationship. So I can say any relationship or any relation having mathematical representation can be called functions. Okay, so function is a relation. So relation is the more basic, and function is a subset of a relation. Relation can be mathematical or non-mathematical, quite possible. Function, we don't say non-mathematical. Function is only mathematical. Then the question is how we represent the function. So let's say f is a function. Function is the relation which you define, which you define, which you define. So f is a relation such that from where to where. So we always write the function or the relation from the independent to the dependent variable. So we write f is such that, this is the colon symbol is called such that. So how we read this entire symbol? We say f is a function, or the formula. You can say y is a function. F means function. F means formula, a mathematical formula. So f is the formula which relates the set x with set y. Okay. So I have a set x, I have defined, I have a set y which is already defined, but I want to know the formula of the dependency of these two variables, these two sets, and the answer is y is x square. So f is a set such that it goes from, f is a function such that it goes from x to y, or it is defined from x to y. It is defined from x to y.
Sir,
Yes.
Sir,
Yeah, tell me.
a relation is subset and or equal to A into B, means A set uh, into B set. So, sir, in function also the same situation must
Yeah,
be
when we, yeah
aligned.
when
No?
we when we define a function, then we directly write the function as a relation between the ordered variables. Let's say I have taken small x and small y as a ordered list. So whatever the relation between these two are, you have to write here. So the f represents the x small x versus small y relation, and these are the
So,
set
sir,
in which
sir, can we show a relation between two different sets without any without any multiplication between the
uh, you can always show relationship, okay, by defining it. So you have to define what you want to define. Let's say, so let's say, as I said in the previous example, look at this here. Here I said this is a relation which I am looking for, so I got these values. I said I want a relation here, here this one, so I got these values.
So, sir, that x is smaller than y is a function.
Yeah, it's a function.
Yeah.
Everything which you define is function. So it's a mathematical relation. It's called the logical relation. So everything is mathematical. It can be mathematically, you can say inequalities, and it may be equalities. So there is something called inequality in mathematics. Okay, so you know this symbol x more than equals to 2, y less than equals to 5. These are called inequality. So if I ask you x minus 2 is more than 5, so what are the answer for x? What will be the answer? Will we get one answer or multiple answer?
Sir, anything greater than 7.
Pardon?
Anything greater than 7.
Correct. So you can say we have infinite answer. So it is not always possible that you will solve a mathematical equation or inequation and you will get only one answer. When you solve mathematical equation, you get one answer or two answer or three answer, depending on the kind of it's a quadratic or linear or biquadratic. So even a mathematical equality will not give you one answer. So similarly, we also solve mathematical inequality. Okay, and the inequality always results in a set of answers. So we say that x will have an answer which belongs to all values from open interval 7 to open interval infinity. This is the answer actually, isn't it? So I hope you have learned about the intervals, open and close. Is this part covered in mathematics? Interval?
sets?
Okay, no problem. So it means the symbolically when I open like this is open is called close interval. This is called close open. This is called open closed. This is close close, open open, close open, open close. The close means you include it, the value which you write, and open means we do not include it. Let's say here the 7 and infinity both are excluded. We cannot include them. So we write open interval. If you want to include it, you write a close interval. So let's say if I put an equal sign, let's say x minus 3 is, so x is more than or equals to 6. So here I want to include 6. So I will let x belongs to close 6 but open infinity. Infinity is always open because no one knows the answer of infinity. So we always include it.
So under open interval, sorry, interval can be also written as means square bracket, round
Parenthesis.
brackets.
Yes. You can write like this. But for the problem is for interval to use round. Round is only used for open. It means this cannot be written like this. Cannot be written like this. This is wrong. But this can be written as this can be written as, and this can be written as, only the open we remove by replaced by the parenthesis. Okay. For close we use square bracket always. This is very essential to know. So of course we have two ways of writing it, but for close we have only square bracket. For open we have either square or the parenthesis. Okay, this symbol is called parenthesis. So we have called parenthesis. This is called the curly bracket. This is called the square bracket. So of course you know this. So for set we represent curly bracket. For interval we use this symbol with either this way or that way. Okay. So I hope so. So function is any relation having mathematical representation. Okay. So any relation having mathematical representation can be called a function. But writing this way, which I just wrote here, is very, I mean, not so convenient to us. So Levni devised a way to write it, and the way of writing is known as Levni's notation, which we all prefer writing. So we say that the Leibniz rotation we write for the elements. We write every element y. So here y is part of y set equals to f of x. How we read? Y equals to f of x, where x belongs to the set x, and the f is the symbol which we use for the function. So how we read this thing? This is read as y is a function of x. So you can read as y is a function of x, and you can in your mind you can keep like y and x will have some formula. That's it. For example, if I'm adding y equals to 2x plus 1. So on the right side, this represents the linear equation, right? Linear value or linear polynomial. So on the right side we have a linear equation, and the left side we have y. So y depends on this formula. So what is fx here?
2x plus 1.
Correct. That's it. If I write y equals to ax square plus bx plus c, what is fx here?
X square plus 2x plus c.
Correct. If I ask what is f of 1, it means wherever you see x replaced by 1, what will you get? A 1 square b1 plus c. And this we can further simplify as a plus b plus c. So f of 1 is how much? A plus b plus c. So once you define the function, you can also define for other values. Let's say if I say if y equals to ax square plus bx plus c, what is f of minus 1?
A minus
A
b
minus
plus
b
c.
plus c.
Very good. So f of minus 1 is a minus b plus c. Okay. But if I ask you what is f of 1 by x?
So a by x square plus b by x plus c.
Correct. So it is like a plus bx plus cx square by x square. So I cannot anything there, and just replace the variable everywhere by the new symbol which I put there. So let's say if I define y equals to x upon x plus 1. So what is the value of y of 1 by x?
Sir, x upon x plus x square.
right? It's the same value. No change at all.
Sir, 1 will be x square.
No. So what we write is 1 by x upon 1 by x plus 1, right? I can take x below x 1 by x plus 1, 1 by 1 plus x. Sorry, 1 by x. Okay, it will be 1 by 1 plus x, right?
Yeah, sir, it should be 1 by x.
One
Right.
plus.
Yeah,
Yes.
correct. So f of 1 by x is 1 upon 1 plus x. So if I ask you, let's say, uh, now f is not the only symbol. It's like if we have multiple, let's say, variables. So let's say like we use x, y, z. So when you solve a question in which we have more number of variables, you also bring a newer symbol for the variable. Let's say you say x for one dimension for one variable. You take x and y for two variables. You take x, y, z for three variables. You may take x, y, z, w for four variables. X, y, z, w, v for five variables. So when you solve a equation with a greater and greater number of variables, you need to devise a way to write it. So imagine if I give you a question of a variable 26 variable, then how will you proceed?
X to Z.
So that is a very bad way of writing. Okay. For two, three variables, the x, y, z is a good way of writing. So also we need to learn that how to write when the number of variables becomes really large. The answer is we use the subscript notation. So we write let's say x1, x2, x3, x4, and then this we can write any number. You can say xn. N can be 100 also. So when we have a large number of variables, we use a subscript notation to represent it. For a small number, we use x and y. That is a simple way of using it. It's not a convention that you must use x and y and like this. Okay, there's no convention like that. So whenever we come across a question in which we have a 3, 4, 5, 6, 7, 8 variables, so we use this. This is the variable. This is I am representing as a variable. So similarly, a function, if you have only one function, you say f. Okay. If I say there are two functions, we will say f of x and g of x. If I say three functions, then say you say f of x, g of x, and h of x. It's like the alphabet sequence in English alphabet. You know, A B C D E F G H G H I. So if we can choose f or g or h, let's say it's like choosing x, y, and z. But when we are facing with a large number of functions, not restricted to three, then I will not use this way. I will say f1x, f2x, f3x, fnx. So this way of writing will ease out the burden of picking the different notation. So I hope that the function way of writing is not only restricted to f of x. You can say g of x. You can say h of x. I mean, like no one can stop you. Okay, so that is a very simple thing that no one is going to stop you from writing the way you want to write. Okay, so although it is started with fx, but it is not fixed to fx. You can say gx, you can say hx, or if it is even more, then you can say f1x, f2x, f3x, f4x. So let's say I'm solving some sort of equation, and then I come across four very different dependencies. So I say f1x equals to 2x plus 1. I say no, f2x is also that is x square minus x plus 2. Someone says no, no, if one more is also variable, there is, it's like, ln x, someone comes, no, no, this is something or more, it is like exponential x, like, you can say whatever you want. So here we have four functions, okay, and every function is defined differently. And but in every function, the variable is x1. That's a good news. We have variable as x1. So now we are also in a situation to define something called composite function. Okay. So before I go to composite function, first try to understand what is function. So function is like a machine which takes x as the input. It processes something. It will churn out the x and will create something. And after doing the processing, it gives you y. So the way of saying is that x is a variable called independent variable, or you can say input. Function operates on the variable, so operator, and gives us the output called y. Okay. But let's say we have a multiple machine. So if we can imagine this is like a dough forming machine, like, you put the flour and water, you add, and it gives you dough. Okay, so in any manufacturing plant, let's say if we have some bakery factory, just over. So you might have seen some videos of the food processing plant, in which the food processing undergoes multiple stages. Okay, so you first, it goes to this stage, then you get the output of the first stage, but the output is not the final output. So the dough will go through the some other stage, in which you will add some sugar or some other ingredients, maybe you chopped cashew and all. Then it will go to the next stage, in which you will bake it, and then you'll go to the next stage, you will put in a packet. So there's a packaging. So the food processing undergoes multiple stages, in which the output of the first stage act as the input of the second stage. Okay. So let's say I have multiple stages of the processing. So the first processing is called F1x, and whatever is the output is not restricted. I'll just use two functions. I'll use f and g as of now. So it will go to the first stage called fx. It will have some output here, but this will not be restricted. It will go further to the next stage, which is gx here. It will also process something, and then you get the final output. So the question is, if we have multiple function in which the input goes, so then how to write this answer? So this is simple way of writing. This is called the composite function. When the function itself is fed in the input of the another function. Okay. So here the first stage will give you fx, and the fx will go into the input here, and it will process. It will give you g of fx. So here it's a function of a function. So y is called composite function. When we have multiple function, not only two, it's a two, it can be 2, 3, 4, 5, whatever. So it is called composite function. This is also written as gf of x. It is also written as yeah. It is also written as this way, or it is also called g of f of x, gof of x. So these are some of the symbols that you will come across in the definition of composite function. I have taken two. Let's say if I have three stages of manufacturing, and so the first stage, what will enter is X. It will process and it will give you X. This will become the input for the next stage, and it will give you fog of X. But even this will become the third stage input, and now you will get the Y. So Y will be H of F of H of G of, sorry, I have written opposite. This will become G of F of X, and then I will get H of G of F of X. So Y is the triple E composite function HGF of X. You can write like this, or you can write this way. Okay. So these are the ways in which you can write H of G of Fx, or you can write like H of G of F of X. And now this is very, very important. Okay, we need to understand this is very important. Why it is very important?
Sir, please you do tell what is that
Pardon?
said. Please will you repeat your question?
No, no, I am saying that okay. You are saying to repeat the question.
Yes, so you asked any question because
No, no, no. I haven't asked. I'm saying that okay, this is the way of writing it. So when any input undergoes multiple function in a sequence, then the final output is called a composite function. Okay, so function of function is called composite function, and it can be 2, it can be 3, it can be 4, it can be 5. Okay, so it's very easy, it's not difficult. So if I ask you what is f1 o f2x, from this answer, from this collection of formula, can you tell me what is f1 of f2x? Yeah, what is input? Can you tell me what is input?
X.
So
What is input for the f1?
Sir, for F1, the input is F2x.
Yeah,
And
f1 will,
for F2,
yeah, correct. So f2 will take x, but f1 will take whatever you get from here. So f1, and what is f2x? Right? But what is f1x? Twice of whatever is the input. This is the answer. So f1 f2 x will give you 2x square minus 2x plus 5 after simplification. Is it very difficult to understand?
so why in the end is plus 1?
This is the formula. This is the input. This is the input. So you put this here. The x represents the input.
Yes, sir, understood. Yeah.
Yeah. So let's say I'll give some. Let's say f of x is sine x. G of x is cos x. So what is fgx? What is gfx? Can you tell me?
Sir, fgx is sin x cos x, and gfx is cos x sin x. With the
Yes,
same.
f of gx is sine of cos x. So here cos of x will act as the angle, and this is cos of sine x. Here sine x will act as the angle. So here x represents the angle. So these are the angle values. Okay. Anyway, so if I say that fx is ln x and g of x is a power x. So what is the value of g of fx? Tell me answer.
So log of a with base e. I mean a raised to x with base e.
Yeah, that's fine. So what is g of f? I'm writing this is g of fx.
So that only log of a raised to x with base e.
It is a to the power ln x.
Yes, sir.
Yeah, because you're writing fx as a input for the g variable, the g function. So here I'm substituting fx. So I'm writing fx here. Because when x is here, so x is here. So when the fx will come here, then fx will come here. So if you just substitute, you will get this answer. It's not difficult. Okay, so in the same question, what is f of g of fog of x?
So it will be ln a to the power x.
Can you simplify this further?
So log a raised to x with base e.
The power gets multiplied, huh?
Yes, sir.
So you can write like this. X ln. Okay. So composite functions are also not very difficult to express. So function, when you see a function, you have to think it's a relation between the variables. The relation will be defined prior to your information. They will give you that this is the variable, this is the relation. Okay. It can be linear, it can be quadratic, it can be logarithmic, it can be exponential, it can be any complex function like we can create. So I will introduce you some uh, types of function that you come across. So we have a function called trigonometric function. So again, it's not a big deal. The moment you see trigonometric function, it means it will have sine, cos, tan, cosec, cot, sec. Like so, any formula which you write involving these things, sine, cos, tan, cosec, cot, will be called a trigonometric function. Okay, it should be sine, cos, tan. Imagine if I if I write y equals to sin x whole square, what kind of function you will say this?
So
Hmm.
I got disconnected. So y is equal to sin x raised to square. Is it?
Yeah, it's a, let's say I have written this. So what kind of function will you say this? So look at this. This function I'm defining this. So let's say I have the processing having two units. The first will enter the x. I have x square. I have a, sine x here, and here we have the square function, and then I'll get the y. What I'll get y? Can you tell me what I'll get y? So x will enter the first box, will emerge as a sin x. The sin x will enter in the second box and will emerge as a sin x whole square or sin square x. So basically, what I have written here is called the composite function.
So
Because
does it
in
comes under trigonometric function? What you have written the header?
yes, we can write this is a part of a trigonometric function because eventually it's a trigonometry. So even a composite function can be a trigonometric function. Now, why this is so important? Because the moment you see sine square, it's not just sine, it's not just cos, it's not just a sec or cot or something. You square it. So it means actually there are two functions involved. And this kind of perspective will help you in learning the concept of differentiation. So when we learn differentiation, you will realize that how important it is to understand that it is something called composite function. Let's say I'll give some more example. Okay, so first we'll write one down. It's a trigonometric function. Of course, because it's a function of sine only eventually, but also it is a composite function. So it's a trigonometric function which is squared, and squaring comes under the category of called algebraic function. Okay, so we also have something called algebraic function. So what are the algebraic function? All polynomials, all polynomials are algebraic functions. Okay, to your information, even the monomial is also a polynomial. Okay, it's under the definition of polynomials. If I had y equals to x, even this is called a monomial, but it is a part of polynomial. You can say subset of polynomials. Okay, it's monomials, polynomials, monomials. We have binomial. If you have seen this term, not express y. Yeah, it's binomial. So we have two terms, not like this, but it's good to say like x. Yeah, so it's like a binomial. The nomial is a word which means terms. Poly means many and nomial means terms. So many term is called polynomial. That's very simple. So the if we have only one term, we say monomial. If we have two terms, we say binomial. And the counting of terms is done by the plus or minus symbol. So how many plus minus symbol we have, which is separating? So you have to count the parts. If I write something called x into y square okay, into z plus y square z plus x y z, and if I write this is equal to t. So on the right hand side, what kind of a polynomial we have? How many terms we have? We have only three terms. We have just three terms. One, two, three. It's a trinomial. It is a trinomial. So in mathematics, the polynomials is basically the number of terms which you write in terms of variable with either plus or minus sign. But the most important concept is the power of every variable must be an integer. So you cannot put a 0.5 or 1.5 or 2.5, and you cannot end up saying, oh, it's a polynomial. That's wrong. So the rule of polynomial is you must be writing as a sum of values, and every value must have integer power raised, and all power must be positive. Then we say polynomial. So the rule for polynomial is that the power of variable must be greater than equals to, okay, must be belonging to, you can say, positive integer. Set of so we write integer as z plus. Okay. Okay, or zero we can also include, including zero. So set of all positive integer, including zero, you can say add zero also. Zero should not be missing. So the even a constant. So when I write y equals to 5, even this is a polynomial because we can write 5 as 5 into x to the power 0. So here we have a variable and 0 is the power. So even a constant represents a polynomial. Okay, so we need to differentiate between the algebraic equation, trigonometric equation. Then what type of equation we have also in physics, mathematics? So we have logarithmic equation. So logarithm with base other than e or base e. So this is two different. One is called the base other than e, and one is base e. The base e is called, or we write as ln x, and basically the ln what has come from the Neperian logarithm. But this is also called natural logarithm. And you may be wondering why it is called natural, because in nature, the laws of science. Okay, I will tell you something very interesting about the function in nature. Okay. In nature, we have three types of function, essentially. Okay. Let's say talk about the rusting of iron. What kind of process you will say rusting of iron? Is it a very slow or very fast?
Slow.
Very slow. Yeah. If you stand in front of iron for 1 hour, will you see the rusting happen? For sure. The chances are very less. Yeah. So the nature is having three types of a relation, which is the most abundant uh, in terms of observation. The first is called the very slow process. We have very fast process. Let's say you fire a cracker and it bursts. How much time it takes from burning to burst? Very less time. Okay. So there are chemical reactions which take place in no time, because the explosion is called the very fast chemical reaction. It's called explosion. So in chemistry, we have two extreme definition. One is the rusting, which is the very slow process. Other is the explosion, which is the quick process. You have a dynamite, you uh, fire the dynamite and it will boom. Okay, it's no time. So to deal with such process, which are either very fast or very slow, we have two different mathematical functions. The one is called logarithmic, which we model for the very slow process. And other is called the exponential, which we model for the very fast process. So now the idea is whether I explain the exponential or logarithmic, the base is not need to be e only. So exponential means any constant number, any constant which is positive and not equals to 1. So if we have a constant which is neither positive, which is neither negative, non-negative, and not equals to 1, if you raise any power here, then this is called exponential function. So it's a very common mistake that if I write this is exponential, if I add 2 power x, this is exponential, if I add 5 power x, this is exponential, if I add e power x, this is exponential. Exponential is the base is a number and the power is a variable. So how to identify the exponential from the algebraic? Because if I write x power a, it's a quite different. This is called algebraic function. So the distinction is very important. When the base is variable, power is constant, we say algebraic. If the of course power is following the rules of polynomial, the other way it's called exponential. Okay. So I will just write this. Okay, a power x is exponential, but x power a is not exponential. It's a algebraic function. Okay. So any number to the power variable is called exponential function. In nature, because this is very commonly found, so we call this as the e raised to power x. It's called the Euler's constant. What is e?
Constant.
Yeah, it's called e is called Euler's constant. In French literature, I mean French dialect, we say Euler's. So we say Euler's. Like when you read it, it's like Euler's constant. So depending on the country of origin, people are saying it differently. If you watch the YouTube videos, so sometimes you will see the Euler. Someone is saying Euler. Uh, I will say Euler because बचपन से मैं ये बोल रहा हूँ. ठीक है. मैं गलत बोल रहा हूँ तो गलत सही, but Euler's. E is called the Euler's constant in the honor of the great mathematician again. Euler is the name of mathematician. Don't worry. So the exponential function signifies something rapid growth or rapid decay. Okay, so how to represent the rapid decay? When the power becomes negative, it's called rapid decay. And when the x, of course, rapid decay when x is positive. And if I write a power x, and if x is positive, it's called rapid growth. So in physics, the decay and growth are very common. For example, if you have learned class 10th physics, you have heard about something called radioactivity. I think radioactivity is a part of maybe 9th or 10th, I don't remember. Have you heard about radioactivity?
Yes, sir.
Okay. In radioactivity, we have something called decay. Yeah, so we use the radioactive decay. So the radioactive decay is the rapid decay. Okay, it's an exponential relation. So when we will derive the formula of radioactive decay, you will see it's an exponential decay. So it's the something constant to the power minus variable. So normally we write as you will get a term like e to the power minus lambda t, where lambda is some sort of constant called decay constant, and t is called time. So something which decays with time very rapidly. So we have the exponential decay formula. So there is something very famous formula like this. Now this term, the decay or the growth, is very common. If I talk about the microorganism culture, when you develop the bacteria in a lab, so the bacteria will multiply in which fashion? Exponentially or logarithmic? How do they multiply? So they multiply exponentially. Yeah, right. So they multiply exponentially. But let's say if I talk about something in physics very interesting, it's called the noise level. Okay. So when you go for a, let's say if you go to a temple for a prayer, let's say uh, what is this temple in Raja? Siddhivinayak. So you go to temple of Siddhivinayak and there is a prayer going on, the morning prayer, early morning prayer, and they are like maybe 10 or 20 or 50 devotees there, and they are shouting or chanting the mantras. There is some noise level, not noise, sound level. You can say it's a good, I mean, of course, it's not noise, but in terms of physics, there is a level of sound. But imagine if the instead of 10 devotee, if the 100 devotee come for the same prayer, same chanting, and if all start chanting in a same level of intensity, so what do you think? Will it become the sound intensity become 5 times because we have 5 times more devotees than before, or will it be less than that? What will be the effect on your perception?
Some more.
So the loudness of the sound will grow. So will it grow proportionally, exponentially, or logarithmically?
Proportional.
Now, for your surprise, the loudness level of sound always grows logarithmically. It means the sound which you, the 10, let's say in a class, if there are like bunch of shaitan students in the class and 10 students are shouting. So if the class with 100 students will start shouting, the noise level will actually on a perceive, when a perception level will only become double. And if you bring 1000 students, then the loudness will become only triple actually. That's very interesting. I mean, observation that all these the noise thing having the logarithmic dependency on the number of people shouting actually. Okay. So not only this, even like we have nowadays COVID going on, and the COVID will have a graph. You know, if you plot the graph, so we say graph flattening. So every pandemic will have a, the disease hit patients, recovery, and those who are having the healthy life so far not affected at all. So if you have heard this the COVID graph, like the number of people are getting affected every day, so there is sudden spike. So the graph you will see will be exponentially, it will grow exponentially in the beginning, but after large number of cases, when we have less number of people left with like negative cases, all are affected. So the growth of number of people affected on a daily basis will decrease. Let's say the first day we have sudden spike, but the second day you will have less spike. Third day will have even lesser because let's say the number of people left is less, and then fourth, and then this. So if I draw a smooth curve, it looks like a, this is called the curve flattening. Okay, so every growth story will go through the some spike and then the flat part. Okay, so we are waiting for the flattening to happen. So we had a lot of exponential growth for the last few months, but now the curve is flattening because that's anyway nature. It's anyway, whether you want it or not, everything will subside. Okay, eventually. Okay. So the logarithmic function and the exponential functions are functions of our day-to-day life, and it's difficult to observe things around us and map it as a logarithmic or exponential, but at least at a understanding level you can see things. Okay, so let's say, like I gave you the example of the bacteria growth in a lab, or maybe the virus, the pandemic expansion across the world. So these all are kind of exponential function, right? And every exponential function will meet the fate of logarithmic function. Okay. So you start with very rapid growth, then you will start flattening. So the exponential and logarithmic are like the twins. They keep on moving one after the other. So if one will dominate for some time, the other will come. So let's say the world population is just increasing rapidly at exponential level, but the resources are not growing exponentially. So there is again the problem will be there. So now the population control will come after some time in every country. So soon you will see the population control bills coming in almost every country, because you cannot keep on generating the resources and meeting the demand of the people. So this thing will happen. So I wanted to give you the real picture of these functions. These are not just functions. Okay, these are something the harsh reality of our life, and we come across this function very often. So the exponential or logarithmic functions are part of the finance also. If you learn the finance, if you do MBA, you will come across exponential function more often than ever. Okay, then you will come across in the JE preparation. That's very interesting, because when you know about the compound interest, so the compound interest over a long term become exponential. Okay, so for few years, it is like a some kind of quadratic or maybe cubic or uh, biquadratic up to 4 years. But as the number of years will grow, it becomes exponential in nature. Okay, anyway. So next. So we have something called inverse function, or basically not inverse function. This is called inverse trigonometric function, and it is nothing to do with uh, the trigonometric functions are different, and inverse trigonometric functions are quite different. So inverse trigonometric functions having very interesting notation, and notation is sometimes very confusing also. So I will try to eliminate the confusion. So let's say from the basic trigonometry, you know that what is the value of sine uh, 30 degree?
1/2.
1 by. So sine, what is sine? Sine is SINE. Sine is a like a name, and it is like an operator. So we say sine as an operator. So when you operate the sine concept on a number called 30 degree, which is called the angle, you get a number. Okay. So when you say sine 30 degree, you basically say that the sine of angle 30 is half. But in terms of writing, we write only SIN. And then we have something called cosine, which means complementary of sine. But we, in short, we write only cos. So complementary means 90 minus angle. So if you subtract the 30 from 90, you get 60. So the cos 60 is same as sine 30, and that's why they are also always there. So sine and cosine are called complementary of each other. So we have many complementary. Now the idea is, if sine of 30 degrees half, So if sine 30 is half, the other way of asking the question is, what is a sine inverse of half? So we say the sine inverse of half is 30 degree, or you can say pi by 6 radian. So sine inverse is not like a power is -1. This entire thing is a symbol or a notation, and this is not equals to 1 by sine. But this is a very common confusion, so I wanted to just put it bluntly here, that, or explicitly, that you should not get confused. It's a notation, and it is read as sine inverse. So sine inverse of half is pi by 6. Similarly, if I say cos 30 degree is how much? How much?
1 upon root 2.
Huh? Cos 30 is how much?
No system.
Come on, guys. What is cos 30?
Root 3 by 2.
Hmm. Yeah. So what is 30 degree equals to, what you can write? 30 degree equals to cos inverse of this value. So if I write, let's say, sin x equals to 4 by 9. Now you have no idea what is the value of angle for which this happens. So while solving question in physics or mathematics, when we come across something like this, and they are asking that write the angle. So what if we can write x equals to how much? So x must be equals to sine inverse of. So because we don't know the value, we just leave like this. We don't disrupt further. We just write like this and we leave it. So for example, if I ask you what is tan 45,
1.
so we can write 45 degree is nothing but the tan inverse of 1. So I think inverse functions are having the symbol like sine inverse x, cos inverse x, maybe y, tan inverse x, and the other also 3 more, cosec inverse x. So we have, these are called inverse trigonometric function. Now you need to realize these functions carefully while solving questions. We need to be able to at least figure it out that it belongs to this category. So we have inverse, logarithmic, exponential, trigonometric, and of course algebraic. Okay, so these are the functions that we commonly have a name for it, and the function which we cannot name it, we say implicit functions. So the mix of all is called implicit function. So implicit function is not exactly this, but it is a function in which we do not know the real meaning of the function, how it is exactly. So we have implicit functions also. We will explore in the uh, something called differentiation chapter. Okay. So now I am interested in the popular graph. Okay, so we'll first learn the graph part, then we'll go for the. But I think before that, I will explain something called domain. Okay, so I'll first use the concept of domain and range. So we'll not go into the mathematical detail of domain and range, but we'll try to understand what is domain and what is range. And there's one more term that's called codomain. So we have three types of concept: domain, range, and codomain. Okay. Just a minute. Okay, so we have three things. One is called domain, range, and codomain. Okay, and we'll explore a bit about all these things. Domain. Uh, okay, it's a very common term, which means domain means like where you have a meaning. Okay, so where you get your meaning. Domain means on a number scale, we have variety of numbers. Like say you know the real numbers, rational numbers, integer, and the natural numbers. So quickly we'll go through all types of number. Natural number or the set of natural numbers, which we represent by the n with a double line like this. So what is natural number? So natural numbers are like counting numbers, right? We say 1, 2, 3, 4. These are called natural numbers. So on a number line, we have a natural number. Now we ask about the rational number. So what is rational number? Which is in terms of fraction, like number which you can write as a fraction or as a ratio of p upon q when q is not equal to 0. So any number which we can represent as p by q is called rational. Okay. So every natural is a rational, but every rational is not a natural. What does it mean? I can write 1 as 1 by 1. I can write 2 as 2 by 1. So it is a rational. But can we say 1 by 2 as natural? Can we say 2 by 3 as natural? Yes or no? Can we say 1 by 2 as natural? Is 1 by 2 countable number? Hello, hello, hello. 1, 2, 3.
No,
No,
sir,
sir.
1 by 2 is not a natural number.
Right. So every natural is a rational, but every rational is not a natural. What does it mean? Who is bigger in domain?
Rational.
Right. The rational is bigger in size, bigger in domain. So let's say I talk about the real numbers. So real can be natural, real can be fraction, and real can be in fact irrational also, like root 2. So now the real can take bigger, chunk of the number line, not bigger chunk. In fact, I would say the entire chunk of the number line. So the real is the greatest of all set, isn't it? So the domain of real is much bigger than domain of rational, and the domain of rational is much bigger than the domain of natural, because root 2 is not a rational, root 2 is not a natural. So we all know that the square root of 2, square root of 3, square root of 5, root of 7, root of 8, root of 10, root of 11, all these number represents irrational. Okay. So okay, the real number is really big. So I'll just I'll go for here from in a sequence. So let's say I talk about the integers. So integers, the set of integers can be negative value, can be 0, and can be positive. So in the number line, which one is more? I mean, which one is the two? Which of the two will have bigger domain?
Integers.
Integers. So now after integers comes the rational. So we write like this. Something like this. A Q with a, I mean, a dot. It looks like this. Anyway, just at Q only. So, so, so the rational is having bigger domain than the above two, right? So because we can have anything in terms of p by q, where q is not equal to 0. So you can write any number as a rational, which is whether it's a natural or whether it's integer, you can write as rational. And then after rational comes uh, the irrational number, but for that there is no symbol. Then we have the real numbers. So the set of real numbers, which you write by r with one extra line, just you add one more line to make a set. Set means all collection of the real points on the number line. So the smallest is natural, the bigger is integer, and then even bigger is the rational, and then even the biggest one is the real, which encompasses rational, irrational, integer, everything. Everything comes in this picture. So when you define a function, then it is not necessary that it will pick all values. Yes, whole number. Yeah, whole number means basically uh, including zero and naturals. Basically, whole number is a concept which you define for the school and colleges, but when you go for advanced study, whole number is not defined. We only take natural as the whole. It means you just add zero. So the natural with zero is called n0. This is called n0, which means you have to include zero also. So this is also comes in the category of natural only. But at the J level, the books, the text which we have, they talk about the natural from one. In graduation level or maybe master's level, the natural text plays the role of whole and natural both. Anyway, so we have natural, we have integers, we have rational, we have real number. So real is really vast in terms of its variety. It can take rational is somewhat limited. It cannot take all irrational values. Integer can only take integer values, including zero and the positive, negative both. The natural is counting numbers. Okay, so these we have these. I mean, the set of numbers and their representation. The domain is like where which of the possible values I can take. Okay, so what I am eligible to take. For example, if I define y equals to 1 by x, so which number x can take and x cannot take? Can it take all number on the real axis or real number set of real numbers?
Zero.
Yeah,
Can be 0.
correct. It can take every value on the real line or real number set of real numbers. It can take every value of set of real numbers except one value, which is zero, because at zero it will lose the meaning of its definition. So mathematically, what we can say that the domain of x, so we write it as dx, let's say domain of x belongs to the real number except zero. So you can choose whatever value you want, but you cannot take zero. So this is the way of writing it. The other way of writing is domain of x is
Sir, I disconnected, sir. Sir, what I asked the question, what does domain really mean? Sir, you answered it.
just yes, you're saying something.
Sir, I got disconnected. Sir, please will you explain the meaning of domain?
Yes, so I'm saying that okay. First of all, you understood the different set. So the
Yes, sir.
natural, integer, rational, and real. These are four most probable set of numbers. The number in a set theory we say these are the famous mathematical set. Okay, which we need to know. And there I'm saying that I define a function y equals to 1 by x. Then the function can take all values accept some values, and the values which it can take is called its domain. Domain means where you have a definition, where you have your definition is valid. So domain is like the checking of the validity of the equation, when the equation is valid and when it is not valid. So when I write y equals to 1 by x, then I say it is a valid value, valid formula, but it is not valid at a 0. So the domain of x is all real set of numbers except 0. So the way of writing is r minus curly bracket 0, or the other way is r the backslash 0. It means r except the right side. Just remove this. These are the two notations in which you can write. Okay. I hope this is not very difficult. If I write y equals to under root of x minus 2, what is the domain of x? Domain we define for input. Remember, the domain we define for input. So what are the values that input can take? Can you guys tell me?
Sir, no, non-zero. No, sir. Zero. X
all
cannot
real
be
number.
less than 0 or equal to 0.
Yes.
Pardon?
X cannot
Sir,
be
sir. No, sir. X
less
cannot
than
be
0.
less than 2. 2. And
Yeah.
yes, X cannot be less than 2.
The only idea is the number, but whatever is inside the bracket can be either 0 or positive. So x minus 2 should be either 0 or positive. Then we can define. So x must be more than. So it can take all real values equals to and greater than 2. Okay. So x can take all values greater than equals to what? 2. So how to write the domain of x or domain of input? What you can write domain here? So you can say domain of x will be close interval to an open interval infinity. So this is the notation or the way of writing. So this is the domain of x. Okay. So most of the function, you have to identify the domain. Let's say if I write y equals to ln ax, or let's simply say ab. So for what values of a and b the log is defined? Do you know the definition of log a and b? Is a logarithm done in math class?
Yes, sir.
So what is the definition of ln a and b? How we define?
So is it ln a raised to b?
No, not ln. Sorry, log x, not ln. Actually, my bad. This is log of. So when you define, not it's better at a b. Log of a base b. So what is the set of limitation on a and b values that we can choose here?
Sir, x belongs to
No, there
r
is no x here.
minus.
There is no x
Oh,
here.
sorry,
We have a and b. You can talk about a and b. I want to know the domain of a and domain of b.
So a and b belongs to r minus 0.
No. Can be. I mean, can a be negative values? Is it possible to have a negative value? Can we take b negative value?
So we can take b negative. Not in.
Okay. Neither a nor b can be negative, first of all.
So why b can be negative?
No.
If
The,
we
how
take
can
minus
how,
the
square, then 4
base
minus
cannot be 0 and a and b cannot be negative.
correct? So A and B must be positive, and the second condition is the B is having one more additional condition. The B cannot be equals to 1. Okay, I will tell you what is the log actually. What do you mean by log? Log is called the inverse of exponential. Let's say I want to write y equals to 2 to the power, let's say 10 to the power 2. And how much is the answer? 100. Okay, so I'm writing like this. Now the other way of writing is like log 10x. You know what is the meaning of this? What you write here is called the base. Okay, this is called the power. And what power you must put on the base to get this number? Like the idea is for what value of the base, like what I should put here to get the value here. That is the meaning. Okay.
Sir, so minus negative can come, no? If we take minus 2 raised to 2, then answer will come 4.
Okay, that's correct. But see, in the definition of exponential, the base is always taken as positive number, not negative. Now you may be asking why. The exponent is defined for the positive base numbers, not for the negative base numbers. Okay. So if I ask you what is the value of 2 to the power 0.5, what will you say? It is the square root of minus 2. And the root of negative number is not defined.
Sir, it will come root 2i.
But that is not definition. That's not the value. What is the value? That's called notation. Notation cannot be value, no?
Yes, sir.
So you end up, devising a way to write something. But it does not mean it will have some physical meaning. In the realistic scale, what is the value of root 2? Minus root 2. There is no value associated with it, right? So that is why if you choose negative number as a base, then you may get stuck when the power is a fraction. So to avoid this awkward situation, the base is always assumed to be positive. That's why the base cannot be negative. And that's why I said the B is always positive. Now the simple question is, if B is positive, so positive to the any power, whether it's negative or positive, a positive number, if you raise to a power which is positive or negative, what will you get? A positive number. Are you getting a point?
Yes, sir.
So this is not wrong. This is like 2 here. So the idea is, when you write a logarithm, the base is the base. So the base of log is the base of the exponential also. And A is the number which you want to obtain. A is the number which you want to obtain by putting the suitable power of B. So what power of B you must put here to obtain the A? That's called the meaning of logarithm. Like for example, if I ask you log 2/8. So what power of 2 we must put to
3.
get 8? So you will say 3. So that's why the answer is 3. The meaning of log is the base raised to the suitable value to obtain the value we are looking for. And base must be positive. And since we are dealing with the positive numbers, so the number which you will get after raising the power to the positive base is a positive number. So there is no question of getting negative number. Now, look at this. If I want to get 1/8, what I will put here? What the power should be?
Minus
The
3.
answer is minus
Minus
3.
3.
So the answer, the power can be plus 3 or minus 3. Okay, the power can be plus 3 or minus 3. And that is why the logarithm may give you positive answer or may negative answer, but it does not mean it's dealing with anything negative. It deals with only positive and positive values. Okay. And in power term, when you put a negative power, it's a insert theory, you know that you can put as 1 upon positive power, right? So we all know that 2 power minus 2 is same as 1 power 2 power 2. So there is also meaning of a negative power. It's a ratio. It's a way of writing. But again, there is nothing called negative power as an absolute value. Okay. So I hope you're getting the point of what I'm trying to raise here, that the logarithm and the exponential having a relation, one-to-one relation. And what they relate is the base and the power concept. Okay. So in one case, you raise the power to the base to arrive at the number which you're looking for. When you do the logarithm, you try to find the power. So of course, the base is bigger. You need a small power to arrive at the answer. What does it mean is, to use 10 as a base, if I want to achieve 1,000, then how much power is sufficient to bring 1,000? Only 3, right? So if someone is asking you what is the log of 10 of 1,000, the answer is 3. So 1,000 of log is resulting to a number which is much smaller, is only 3. Because the base is bigger, so we need less power to bring this number. For example, if I write a log of 2, 1024. So what power of 2 will bring you this number? Correct. So log of 2 to the power 10 will give you 1024. Okay. And that is exactly the relation between the 1 gigabyte and 1 megabyte, right? So all are power of 10. Okay. So when you go from the power of 2 actually, so when you go from the mega to giga, the power of 2 is taken into consideration in the binary world. Okay. Then from go to giga to terabyte, you just raise one more power of 2. Okay. So on a logarithmic scale, everything is positive. The power can be negative if you want to obtain a fraction, and power can be okay. Now imagine if I'm writing something like this: log 1/2. Okay, and maybe 8. How we can achieve this?
3.
So the answer will be how much? 3 or minus 3?
Minus 3.
Minus
Right. And that is why there is a property that when we have a fractional base, so you make the 2 power minus 1, you can write the base as like this. And the minus of the base comes outside as a number minus. So this can be written as minus 2 base a, and we know the log of 2, 8, answer is 3. So we write as minus 3. So again, there is a property, if you write the base as a 1 upon something, you can make it something and take the minus 1 outside. So all this property follow the simple rule of common sense. I think there is no rule actually, and no need to mug up any rule. Apply the common sense. If I'm asking, let's say, if I'm writing, okay, like log of ln x equals to 2. So what must be x?
Sir, 2.303 square.
This is ln x, but which means log x base e. The question is, the e to the base, power, this number will give you x. X is e to the power 2, that's it. the base to the power will give you x. When you write equals to 2, it means the power of 2 to the base e will give you x. That's it. Okay, I think you have not understood. Log 17 to 89. What is the answer?
2.
So well, you know the meaning. What I'm asking is that the 17 raised to the power 2 is equal to 289. So when I replace 17 by a symbol and I write something here, I don't know now what I don't know the value of okay, whatever. So maybe this is something called t. So what relation I will write here? Tell me.
E raised to t equals to 2.
Correct. So it's not very difficult to convert. Let's see if I write ln x equals to y. So what is x equals to?
E raised to y.
That's it. That's it. Now any number we can write as e to the power ln a. You know, it's the same thing. Or any number we can write is 10 to the power log 10a. Or any number equals to b to the power log b a. You know, all are same. Now you may be wondering how it is.
So yes.
Okay, so what I'll do, I'll just prove it. It's very easy. A equals to, let's say, x. Take ln both sides. Ln a equals to ln x. Okay, fine. Now this looks fine. So ln x is ln a. So what is x?
A.
E power ln. No? Okay, I'm proving this actually. That a can be written like this also. Okay, you didn't get. Okay. Once again.
Yes, sir, I got.
Sorry. So sometimes it is very interesting to write in this fashion. In calculus, you will come across the usage of this very often in solving some of the tough challenging problem. What I'm trying to say that every number can be written as a chosen base into log of the same base into it. It's the same thing. And to prove this, let's say I'm writing, so let's say there is a number called x, which I is equal to a. So in other way, how we can write? So let's say I take log both sides. Take log base b both sides. So we can write log of x base b is same as log of a base b. I hope there is no problem. Now this number I am just let k equals to this number. So I can write log of x base b equals to k, just for writing sake. So what I can write here, what is the ratio between b, x and k? What is the ratio between b, x and k?
X is equal to b raised to x.
X is equals to b raised to k, right? X equals to b raised to k, isn't it?
Yes.
So what is k here? And what was x actually? So that's why I proved that every number can be written as a chosen base into log of the number with the same base. It's the same number. That's why we can write a number a as e to the power ln a. Is it very difficult?
Okay.
Okay.
No, sir.
Okay, so this is very tricky one. Like Normally it's difficult to realize, but it's not very difficult. Okay, so these are some tricks. Okay, but I was talking about domain. Okay, so let's not digress from the domain. Domain of logarithms are very important. So let's say I write a log of okay. So you need not to bother about, let's say, why is this much. So you need not to bother about the base, because base I have given as 10. So, but the number I have written is x square minus 3x plus 2. So that number must be positive, else I will be in trouble. So what values of x can take on a real line, which can keep the equation valid, and the values of on the number line that it can define this function will be the domain of x, the input value. So can you guys try to find the domain of x here?
Sir, x cannot be 1, 2. 1 or 2.
Okay, only 1, 2 or something more?
Sir, 0 also.
Okay. Why 0? 0 we can write, no? If you put x equals to
Sir,
0,
but
then log 2 is fine. Okay, so you have learned the quadratic equation, right? So let's say first you equate to 0 to find the roots, and the roots are 1 and 2, right? So now you have to draw like the sign convention. So 1 and 2 are the roots. So you know the sign convention and how to write it. So if x is more than 2, the answer will be positive, negative. But again, if it is less than 2, it's again positive. Okay. So what are the values we can take on a number line? We can take all values which keeps the term positive. Okay, do you guys understand this part?
Yes, sir.
Yes, sir.
So
Sir, I have a doubt that why the line goes from positive to negative always.
oh, okay, you have doubt. Okay, that's very you write like this. Okay. Now imagine a number which is bigger than the biggest value. So 2 is the biggest value. So imagine a number which is more than 2. Let's take 3 or 4 or whatever. Just take any value and put in this formula. What you will get? A positive answer, negative answer. Let's imagine 3 and put x equals to 3 in the this factor. So 3 minus 1 into 3 minus 2. Will you get positive or negative?
Positive.
Okay. Now to understand the 1 and 2 values, let's put something between 1 and 2. Just say 3 by 2. Check the answer. 3 by 2 minus 1. Okay, that's common. See, any number here will be bigger than 1 and less than 2. So x minus 1 will be positive and x minus 2 will be negative. Understood?
Yes,
So
sir,
the
understood.
product
Yes.
of plus and minus will be minus 1. No?
Yes, sir, understood.
If you choose any number here, it is more than both values, so it will be give you positive, positive. And if you choose any number below this side, both will be negative. So negative into negative is negative, positive. So again positive. That is why we have the convention. It's not convention, it's like common sense. You just factor it, you write the polynomial as a factor and put some random value in the factor for the given range and check the sign of each and just multiply the sign to get the overall sign. Okay. I hope this makes sense.
Yes, sir.
Yes, sir.
So now what is the domain? Finally, my question was domain, right? So the input belongs to what values to keep it valid? So it should be more than 2 or less than minus 1. sorry, less than 1, and you cannot include 2.
Infinity, no infinity.
So we cannot include 2.
It cannot include 1 also, because if you include 1, if you take 1, it will give you 0.
Yes, so
answer.
-1 will come.
No, 0 will come. 1 and 2 will give you 0. No? They are roots. 1 and 2 are roots, so root will give you 0 answer. No?
Yes, sir.
So log of 0 is not defined. No? Yes,
So
what the
0, 1, 0, 1 to an infinity are not.
Oh, it's common. I will tell you what. Tell me the power of 10 which gives 0. The answer is you will never get it. Yeah, you can get a number close to 0 if the x goes to minus infinity, but you will never get the exact one.
Sir, so the number becomes roughly equal to 0.
Yeah, roughly equal to 0. When it is going to minus infinity, it is roughly equal to 0. So the limit will exist, but not the value. So there is no power of a positive number which gives you exact 0. So when log is 0, it is undefined. So that's why we cannot take 0 as a number, and therefore 1 and 2 cannot be taken. If you take 1 and 2, the number will become 0 for 1 or 2, which will make it undefined. And if you take any number which is more than 2, you will get a positive answer, and that's good. If you choose any number which is less than 1, okay, very good. So the way of writing the domain will be, there are many ways you can write in the way you wish. So I can write like this: R minus 1, 2. Right?
Sorry, infinity also, no?
No, R minus, yeah, but okay, this is not the way, because what you said is correct. Infinity is also problem. So we will write only interval. So we'll write x belongs to open interval minus infinity to 1, open, union open interval 2 to infinity, open. This is a way of writing, or you can write minus infinity 1 parenthesis notation. When everything is open, you can use this notation. Yeah, right, correct. So we cannot take even infinity. So this is the way of writing it. Okay.
Sir, I didn't understand.
You are choosing the set of numbers on the real axis for which the term called x square minus 3x plus 3 is a positive number. I want to keep this entire thing positive. So what value of x I can choose? That is my question. Why I'm saying this? Because by definition, log of something is always, so you define log of a positive numbers, right? Or negative numbers? Do you define?
Positive,
Positive.
non-zero.
So by solving the quadratic, I got the location where the quadratic was positive. So what are the locations in which the quadratic is positive? On the number line where the quadratic is positive, tell me. It is beyond 2, right of 2, or left of 1? Left of 1 and right of 2.
Yeah.
So what you will get left of 1? You will get minus infinity till 1. So where
Sir,
you
but minus infinity, we will include minus infinity, no?
No, infinity is never included. Infinity is never achieved. It's a symbol. Can you achieve infinity?
No, sir.
Okay, let's say you say I am at infinity, but let's say if I walk one step more than you, I will be ahead of you. So which one is the real infinity? You cannot define it. If you say that you are at infinity, then is it possible for someone else to go beyond you? I hope you got what I'm trying to say.
Yes, sir. Understood.
Infinity is not achieved, it's a concept only. Okay, I ask you a simple question. Everyone will tell me answer. Which number is next to 0?
Sir, which side?
Infinity.
Let's say on the right side.
1. Positive 1.
Which number is next to 0? I'm saying the number very after 0.
So 0.0000 and then continue with 10 1.
So can you
Sir,
define it?
infinity.
Can you actually put on a paper which number is next to 0?
No.
Can you put on a paper which number is
No,
next to
sir.
0? The answer is no. So there are many things in physics, I mean in mathematics, which you can only understand, you cannot express it.
Sir,
So
the number will come 1 by 10 raised to infinity.
no, it's not way of right saying. Like infinity itself is not defined. So saying 1 by this is okay. It's like just like playing with symbols, but it's still not coming to terms with the real thing. The answer is simple. You cannot define a number next to 0, although it is there, isn't it? So you will say, sir, the next number 0 is 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000and millions of generations will ever be able to reach the number next to 0?
No.
The answer is simply no. Although we know that it's there, but we cannot say it. See the helplessness we have. You are so helpless, you cannot even say number next to 0. And that is why we are learning calculus, The whole purpose of learning calculus is to talk about such things which is difficult to express. So Newton also faced the same dilemma, how to say a number next to 0 or how to say a number next to any number. And the answer is no, you cannot say a number next to any number. And so comes the concept of limits. Limit means you are very close to something, but you don't know how close you are. So there should be a way of saying it. And so we devised a chapter called limits. So we devised a chapter called continuity for the same purpose. See, one small, the question in the brain actually created this entire new fascinating mathematics called calculus. So calculus is to deal with something which you feel but cannot express it. And there comes the calculus will come as a rescue. So calculus will take care of these emotions in symbolic form. So we'll learn, of course, in detail how calculus can be the savior to such awkward situation. Okay. So such awkward situation is very common in mathematics. And so we have, it's like, calculus is not something very strange or something out of blue. It's like a human emotion was there and we were like, feeling pathetic, like what to do. It's like helplessness is there. So we thought of putting the helplessness into some symbolic notations and getting rid of this helplessness. Okay, so at least we have some certainty of saying something. It's very fascinating. So don't worry, we'll learn a lot about the points and this the number next to 0 thing called limits, and then we'll of course we'll go further to understand the entire calculus. So as of now, I started a domain. Domain is like a definitions. Uh, the validity of something is called domain, like the input values which you can choose without hurting the sentiment of definition of mathematics. Okay. So what are the values of x you can choose which will not hurt uh, the mathematical formula, okay, the mathematical definition. So you have to respect the mathematics, and that is why the domain is defined, which gives you the location in which you can pick the values for your own purpose. Okay, the values you can pick are either entire value or you can pick a subset of the real value. And in most cases we get a subset. In many cases we also get the entire value. If I write, let's say, formula y equals to x plus 2, what is the domain of x? What value x can take?
All real numbers.
All real numbers.
Correct. So you can see that the domain can be the entire set of real number or a subset of real number, but you cannot go beyond that. Of course, I mean, if the real line is the world for us, the mathematical world, you can say, if mathematical world is real line, so I can only go for up to real line or a part of real line. So that is called domain. A domain is a very simple concept. Okay? We need to respect the mathematical integrity of a formula, and therefore you are only eligible to choose a part of the real line which keeps the mathematical integrity intact, and that is the end of the domain concept. So we'll also talk about the range. Range is the, of course, the values you can achieve if you choose the values of the domain. So the upper limit of the output for a given input. I'm not saying if you keep on putting the input values, which is for which it is valid, the output will keep on fluctuating. So I want to know that how far the output can go for the any values picked in the domain of the input. So the farthest you can go is your range, your upper boundary. Okay. So a range is again a subset of a real line, okay, in which the output can achieve. Okay, so what input can achieve is called domain, and what output can achieve is called range. Okay. So it is again a part of a real line. It can be a real line, can be a subset of real line. For example, if I ask you what is the possible values of y here, what y can achieve? Y can
So
achieve
all
any, yeah, it can again achieve any real
R.
line. Correct. Okay, but if I ask you y equals to under root x minus 2, what y can achieve? What y can achieve?
Sir, again R.
No. Can you get a root of number which gives you negative answer?
Yes, sir. Sir, then we will get
Only positive real line.
non-defined.
You
Sir,
will
for
get,
x is equal to greater than or equal to 2, we will get positive, no?
yeah, so we'll get the answer only from the x is not real. Na? X is only from 2 to infinity. So y will go only from 0 to infinity.
Infinity.
So the range of output is 0 to infinity. So you cannot get negative numbers. So I can say y belongs to positive, or I'm not positive. This is better. Okay. And not natural. It can take a fraction. It can take any real value. Why? I can put x equals to 2.11.
So no, sir, I am talking about value of y,
So y value is always what?
whole number.
No, why whole number? Why whole number? It can be fraction. Why not? Why can be fraction? No? Why we should do whole number? Let's say
Sir,
I'm
then
putting.
it can fluctuate to real numbers also.
It will only fluctuate in the positive direction of real number.
Sir, in y, one will also
See, I think you're confused. First of all, you need to understand you cannot put any value of x. You can only put the domain of x. And for the given domain of x, what are the possible values of y you can achieve? The answer is I can achieve anything from 0 to infinity.
Yes, sir, understood. Sir, it can be the number close to 0 also, no?
Yeah, why not? Why not?
Yes, sir,
I can
understood.
achieve 0.0000 anything. So the idea is you can achieve any number on a real line from 0 to infinity on the positive side. So range is again either a real number or a subset of real number, okay, which the output can attain for the given domain. So see, your domain is fixed. Now you can only pick the values from a domain, and then you can tell me what is the range of output. Okay. So we'll talk a bit more about range in the next lecture. So we have done with the domain part. Domain part is something like this. You have to practice. If you are eager to practice more, I will recommend go to NCERT textbook of class 11. You have a chapter called function. You can practice from there the domain and range concept. It's pretty easy. You can read it. You can just see the question and you will be able to solve. So conceptually, it's very simple, very easy to understand. And if you have some doubts, again, as I said, we can discuss in doubts. Okay. So probably the tutorial class will be taken by Amit sir. You can discuss there. Okay. So we'll end the lecture here because the time is exceeding. I have other lecture also, and I think you will also have other lecture today. Okay. So
Sir, in next, you will discuss the answers of that USS.
the
I mean,
answer, yeah, the answer of USS, I think Amit sir is discussing next lecture, maybe. And if sir is not discussing, then I'll take. Okay. Because I right now I don't have time for the tutorial because there are many students who are preparing for the JEE advance, and the advance is not ended till now, so the date is unannounced. So I'm a bit busy for 1 month probably. Then of course after that I will take the tutorial. Okay. But still, if you have some doubt, you can ask in the class, not an issue. So I hope that tutorial should answer your question, most of the question. But in case if that is not asking, if you are still finding some sort of you need help, you may ask in the my class, not an issue. Okay.
All
So
right.
okay, we'll see in the next lecture, guys. I mean, take care, be
Thank you,
safe,
sir.
yeah, and keep your health and everything fine, and practice problem. Okay.
Bye, sir.
Bye.